Today we're going to learn how to solve equations that have variables on both sides. Let's think back to these types of problems we've done before. The first step in doing these problems was to use the distributive property. Next, we multiplied through to eliminate fractions. After that, we combined like terms on both sides. And last, we undid addition or subtraction using inverse operations, and then multiplication and division using inverse operations. So how is it going to be different with solving equations with variables on both sides? Everything will be the same. Distributive, fractions, combine like terms, but now we're going to need to use the inverse operations to make the variable be only on one side. Remember, when we have a solution to equation, it's x equals something or y equals a number. So we need to have the variable only on one side of the equation. That's the only thing that's new for this new lesson. Second to last addition or subtraction, and last we undo multiplication and division. Let's look and see what this might look like. Let's do this one together. I'd like you to pause the movie and copy the equation 5x minus 5 equals 7 minus x on your papers. Press play to continue. Let's look at this one. Starting with the steps on the right. Distributive property first. There's no distributive property. There's no parentheses to deal with. How about fractions? Nope, looks like we're okay on our fractions. Combining like terms? I have a 5x and a negative 5. Those cannot be combined. They're not like terms. And I have a 7 and a negative x. Those cannot be combined either because they are not like terms. Let's move on. Isolate the variable to one side. Typically on these, I will look at the equation and I want to see which is easiest to use the inverse operations on. I have a negative x over here and a 5x over here. I think it would be easiest for me to just add a plus x. That would make this negative x and positive x cancel out, and then I would no longer have x on the right hand side of the equation. But I know that if I put a positive x on this side, I also have to put a positive x on the other side because equations are equal. We have to keep them balanced. Pause the movie and write your plus x and plus x on both sides of the equation, then press play to continue. So now what do we have? Let's look at the x, left-hand side. I have a 5x and a positive x, which is 6x. I didn't do anything to the negative 5, so I'm going to bring it down. Equals, I didn't do anything to the 7, so I bring it down. And a negative x and a positive x cancel each other out, so I'm left with only 7 on that side. I've now isolated the variable to one side. It's now time to undo addition or subtraction. When I look, I have a negative 5 on this side. I want to get x by itself, so I can add a positive 5 and a positive 5. Pause the movie and copy this step into your notes. Okay, so now let's see what we have. 6x hasn't been touched, and I have a negative 5 and a positive 5. Those cancel. I'm getting, slowly but surely, getting x by itself, and a 7 and a positive 5 are 12. Now, if I go and undo my multiplication and division, 6 is multiplying by x. The inverse is to divide, and x is equal to 2. Please pause the movie and make sure you have all of these steps copied into your notes. Now this shows us some important vocabulary we need to understand when dealing with these lessons. Identity. Now an identity is when the left-hand side of the equation equals the right-hand side. For example, 5x equals 5x. Now, you're asking why this is an identity and not an equation. That's because x can be multiple things. If x was 1, this would be 5 equals 5. If x is 2, this would be 10 equals 10. So this is an identity in that it shows that x can be many different numbers. Pause the movie and copy down the definition for identity. The next thing we need to know is no solution. Sometimes when we solve variables on both sides, we get answers that come up like 5 equals 12. We of course know that 5 does not equal 12, so we would say that this particular equation has no solution. Pause the movie and write the definition for no solution in your notes. Let's try this problem. Is 2 quantity x minus 6 plus x equals 3x minus 12 an identity? Let's go through the steps. First, the distributive property. I have x minus 6 2 times, so that's 2 x's. Negative 6 and negative 6 is negative 12 plus x equals 3x minus 12. Fractions. Do I need to eliminate fractions? No. How about combining like terms? Let's look for our like terms. 2x and positive x are like terms. 2x and a positive x would give me 3x. The negative 12 stays there, and that's going to equal 3x minus 12. At this point, I can see that the two sides are equal, and I can stop and say, yes, this is an identity. Copy this equation down, this example of simplifying, and then write in your notes, yes, identity. You may pause the movie now to do so. I'd like you to try this one on your own. Solve 6 minus 3x equals x minus 12, and then press play to check your work. Let's see how you did. No need to use the distributive property. There's no fractions. I think our terms are combined. Now it's time to isolate the variable. I'm going to go ahead and get rid of the x on both sides by putting in a negative x. I now have 6. A negative 3x and a negative x would be negative 4x. I might have caught you on some of you on that with the negative x's. So 6 minus 4x is equal to, these x's cancel, and I have negative 12. Here's another tricky part. We need to undo the addition or subtraction. People's first gut feeling is to get rid of this minus 4x. But really, that is the last thing we want to deal with because we want to get rid of this positive 6 first. So we're going to subtract the 6 from both sides. And once I subtract 6 from both sides, I get negative 4x is equal to negative 12 and negative 6, which is negative 18. Now to simplify. Negative 4x, I'm going to divide both sides by negative 4. The negative 4's cancel. I'm left with x by itself. Equals, I'm going to go ahead and keep this as an improper fraction, but I want to simplify it. 18 and 4. I know that they can both be divided by 2. 18 divided by 2 is 9, and 4 divided by 2 is 2. A negative divided by a negative should be a positive. So the answer to this should be 9/2. Check your work. If you made a mistake, please fix your notes so that you have a good example to work from. Okay, let's try one more. Do this on your own, then press play to check your work. Let's see how you did. First, do we need the distributive property? No. How about fractions? No. How about combining terms on each side? I think so. So 4g and 7, those are okay. I cannot combine those. 5g and a negative g, or minus g, that can be combined. So I would now have 4g plus 7 is equal to 5g minus 1g is 4g minus 1. Alright, next we're going to isolate the variable. Let's get rid of this 4g on the right. If I subtract 4g from this side, I should have subtracted 4g from this side. Those cancel. Uh-oh, they both canceled. 7 equals -1. Does 7 equal -1? Absolutely not. I am now finished with this problem because I can easily say that this equation has no solution. Make sure this is what you had in your notes. If not, copy it so that you have something to refer to. Okay, one more. Pause the movie, copy it down, and then check your work. Alright, let's see how you did. Starting with the distributive property. Let's go. 3n and 3 minus 1. 3 times -1, excuse me. That would be 3n minus 3 equals 5n plus 3 minus 2n. Alright, distributive property done. How about fractions? No fractions. So let's go on to combining our like terms. Let's look for our like terms. On the left, 3n and -3. No. On the right, I have 5n and -2n. So let's go ahead and combine those. The left stays the same as 3n minus 3, and the right becomes, let's see, 5n minus 2n, which is 3n plus 3. Okay, so now let's move on. We're going to isolate the variable on one side. Let's go ahead and get rid of the 3n. The 3n. I get -3 equals, positive 3? Again, this doesn't work, so we would say that this has no solution. Copy these notes down onto your paper so that you can refer to them later. Now you try. There's 3 problems. Solve for the variable, and if appropriate, you will write identity, no solution, or in some cases actually find out what the variable equals. Good luck!